Hi guys, my name is Peter Sitagwa Jr., mathematics instructor at University of Liberia and your math tutor. So in this video, we will be discussing finding derivative of functions, probably or we call them radical functions or irrational functions. So we want to find the derivative of this function using the first principle of derivative, not the methods of derivative, but the first principle of derivative, which we derived in previous videos, and you can just check to see the derivation. So these are problems I also gave for you to practice. Now, y equals to f, let's say the square root of x. Now, take notice of the first principle of derivative. Whenever you are asked to use this method, take note that you need f of x and f of x plus h. That's all you need to replace in this limit so that you can be able to solve for that limit. But the problem they gave us, they said y equals to the square root of x. And in this, I'm not seeing any y. But I know that the names of functions can be y, can be g of x, can be h of x, can be p of x, arrow of x, and so forth. So if I have y, I can just change this name y to f of x is equals to the root of x. Now, I have f of x now, which is equal to the root of x. What do I need? I need f of x plus h. That is, I have replaced this x now with x plus h. So I must do the same thing on this side, x plus h. I'm done. So I go to the problem. F prime of x, the limit of f of x plus h minus f of x. That's the formula now. H approaches 0. So f prime of x equals to the limit. So this expression is just equal to the square root of x plus h minus this is just equal to the square root of x, all divided by h as h is approaching 0. So what we can do there is that we can rationalize. So we can rationalize the numerator so that we get rid of the radical. So to rationalize the numerator means to multiply this expression in the numerator, x plus h, the root of x, in both the numerator and the denominator, x plus h, the root of x. But since you have two-term expression to rationalize, you take the conjugate of their signs. So the conjugate of the sign here is positive because this is negative. So you change this sign to positive. H approaches 0. So we rationalize now. We have the square root of x plus h times the square root of x plus h. You will have x plus h. Whenever you multiply two radicals that are the same, you just take one of the radicals. That is what is within inside. Then we come here, the square root of x plus h times the square root of x plus h. You have positive square root of x times square root of x plus h. So I will just do it like this for us to understand, but we could go a shorter way. Then this one, negative, the square root of x times this one is just the square root of x times the square root of x plus h. The square root of x times the square root of x is just equal to x. Negative times positive is negative. So we understand that this expression cancels this expression as h approaches 0. So what are we left with? So we're now left with the limit. the limit of x plus h. Okay, mind you, in the denominator we have h, and then parentheses the square root of x plus h plus the root of x. Okay, so in the numerator now we have x plus h minus x all over h, x plus h plus the root of x as h approaches 0. So this x and this x cancel. So we now have the limit of h all over h times the root of x plus h plus the root of x. So this one and this one also cancel. So the problem now had gone to its simple stage. Very, very simple. So we have f prime of x to just be now the limit of 1 all over the root of 1 plus h plus the root of x. So at this stage, we can test as to whether if we apply the limit in the denominator, we're going to get 0. So you notice that all positive in the denominator, so there's no means of giving you 0. So we can now apply the limit. So we have 1 all over the root of x plus 0 plus the root of x. So h now goes to 0, so this whole thing is just 0. We can move this one out. It's just 0. So the root of x plus the root of x is 1 all over 2 the root of x. So we can further simplify getting rid of the square root within the denominator by rationalizing the root of x. So this can now be f prime of x equals the root of x divided by 2. The root of x times the root of x is just x. So this is now the derivative of this function f of x is equals to the square root of x. Thank you. See you next video.